Theorems of moment of inertia. Yeah, good side heading. Theorems of moment of inertia. ரெண்டு important theorems இருக்கு. Derivations are not important, but applications are very important. So we can say that there are two theorems of moment of inertia. One is parallel axis theorem, and the second one is perpendicular axis theorem. Okay, first let us talk about parallel axis theorem statement and then put derivation and then applications. Applications we'll see like after completing both the theorems. Okay, so first you can keep side heading as parallel axis theorem. So in parallel axis theorem, generally what we will do is if two axes are parallel, if two axes are parallel and one of them is passing through center of mass of the body. One of them is passing through center of mass of the body. Then in the case, let's see one diagram. Let's take two-dimensional lambda, 2D lambda, something like this. 2D lambda is there. Inga center of mass of the body is there. So axis passing through center of mass. Usually we'll call it as I about center of mass. And a new axis which is parallel to it and having a distance d from it is a new axis. Okay. One axis passing through center of mass and another axis parallel to it at a distance d. Then we can say statement I about new axis is always given by I about center of mass axis plus mass of the lamina into d square. If its total mass is m, then I about new axis is equals to I about center of mass plus m into d square, where d is the distance between the two parallel axes, m is the total mass of the lamina. Okay, for that one small proof is there. Let me prove it. Simple case one. So as we consider the lamina like this of mass, total mass, yeah, where center of mass axis is this, is the center of mass point, and parallel axis somewhere here. Still, it is not straight. And a parallel axis here at a distance d or at a distance d. Now, out of this total mass m, out of this total mass m, I'm taking a point mass somewhere here, which is like dm, point mass. Let it be a point mass at coordinate points x comma. So this distance and this distance we need to consider. Why? Because எப்பவுமே perpendicular distance from the axis of rotation the pocket. Okay, so let's take this distance as, since it is x comma y, so this distance will be what? This will be x, this will be what? Y, isn't it? Let's take this is o, this is o dash, and this is y and this is x. So we can say like the situation. This is d, this is x, and this is y. This is, let's say, any r distance. Let us talk about it later. And let us say this is r dash. So moment of inertia about center of mass of that point mass is dm into r square, isn't it? அப்படியே moment of inertia about that new axis, if you see, dm into r dash square, isn't it? Because perpendicular distance to the point p where dm is present from the new axis r dash and from the original center of mass axis r. Okay. Now let us see the relation between r dash and r. Where r dash we can write r dash square, we can write, observe clearly. This one r dash square is nothing but this plus this. I mean this square plus this square, which is d plus x whole square plus y square, isn't it? Expand it, d square plus x square plus 2 into d into x plus y square. Okay, now I'll just write separately that d square separately plus here x square plus y square plus 2dx. Why I wrote this x square plus y square separately? That is nothing but r square only, no? So I can write d square plus this one r square plus 2 into d into x. This is what r dash square. This information I'll substitute in this equation, which is I about new axis is dm into r dash square, which is d square plus r square plus 2 into d into x. Okay, now I about the new axis for that point mass will be dm into d square plus dm into r square plus dm into 2 into d into x. Okay, now see it clearly. dm into d square, if I take it for total mass, dm stands for integral of dm or sigma of dm will be equals to m. Okay, like total moment of inertia, total, not only for the point mass, total moment of inertia about the new axis will be sigma of dm into d square plus sigma of dm into r square plus sigma of dm into 2 into d into x. From where to where? From I is equals to 1 to, let's say, n number of masses are there. I is equals to 1 to n. Like here I, here I, here I is equals to 1 to n. So now this becomes m into d square plus this becomes m into r square only, no? R is constant only, right? So m into r square will be the total moment of inertia about the center of mass axis, which is ICM plus this part you see. See, sigma of dm becomes m, but here the moment of this m, I mean dm into x or m into x, which we will call as moment of the mass. If you look at the diagram, moment of the mass, for example, here one point mass is there. When this object is rotating in anti-clockwise side, moment of this particular mass will be at this instant will be upwards. Exactly opposite point mass if I take, that moment will be what? Downwards. So moment of this and opposite point of this or opposite point mass of this will be exactly opposite and equal. Like that overall body, if you take, net moment will be how much? Zero. So net moment of this particular part will be how much? Zero. So this will be what? Zero. Now the moment of inertia about the new axis for the entire system is I about the center of mass of the total system plus m into this. Is it clear? So moment of inertia about any new axis which is parallel to the center of mass axis is always equals to ICM plus md square. Here the mandatory condition is to apply this formula in any moment of inertia condition. The mandatory condition must be one axis must be center of mass axis. It is not applicable everywhere where two parallel axes are there. It is only applicable where two parallel axes are there. One of them is passing through center of mass. Okay, example paranga. Example paranga. An example let's take. Let's see. There is a rod of mass m and length m. One axis is at a distance L by 4 from one of its ends, and one axis is exactly passing through center, which is center of mass. The question is, what is the moment of inertia about its new axis? இந்த ஆக்சிஸ்ல இருந்து பார்க்கும்போது moment of inertia எவ்வளவு இருக்கும்? அதான் question. புரியுதா? Very simple. One of the axis passing through center of mass only, no? Yes, we can write I about center of mass plus m into d square. What is this distance? Total is L by 2 minus L by 4. L by 2 minus L by 4. How much will come? How much will 4 minus 2? 2L by 8. Up how much it will be? L by. Okay, so it will be ICM. About the center of mass x of the rod, we know the moment of inertia is m L square by 12 plus m into L square. So it will be ml square by 4, you take common out. Here 1 by 3. Huh? Oh, 16 as well. Ml square by 4, you take common out. Here it will be 1 by 3. It is 1 by 4, isn't it? So m is 16. Ml square by 4 into 7 by 12, isn't it? So 7 ml square by 48 kg meters. Any condition like this will be calculated based on this one. Remember, one axis must be passing through center of mass of the given lamina. Maybe 1D or 2D or whatever it is, it must be passing through center of mass. Remember that point alone clearly. Ipo. Let's talk about perpendicular axis theorem too, and then we will see the applications. Okay, let's take perpendicular axis. Yeah, statement enago. If three mutually perpendicular axes are there. இதில் bracketல போடுங்க. One is own axis. Own axis definition already கொடுத்துட்டேன். Already told about own axis. Own axis center of mass இருந்து போனோம். கண்டிப்பா perpendicular to plane of rotation இருக்கணும். Okay. So mutually perpendicular three axes are there. Three axes are there. Out of which one must be own axis. Then I about own axis must be equals to I1 plus I2. இது நான் ஒரு கண்டிஷன் எடுத்து சொல்றேன் பாருங்க. There is a ring or disc இந்த மாதிரி ஒரு கேஸ். இதுல one axis is passing through center of mass along x axis and one axis is passing through center of mass along y and one axis is passing through center of mass perpendicular. இது z. சரியா? இந்த கேஸ்க்கு நம்ம என்ன எழுதணும்னா IZ is equals to IX plus I. Got my point? Moment of inertia about the axis passing through center of mass and perpendicular to plane of rotation is always equals to sum of moment of inertias about the remaining two perpendicular axes in the same plane. Okay, எப்படி prove பண்றது? How to prove it? Very simple. Here one point P is there. X comma y. This distance is y. This distance is x. Now write separately. What about Ix? What about Ix? Point mass மாதிரி எடுக்கலாம். M into I about x, m into y square. When you see from x-axis, perpendicular distance of this is what? Y then. அப்படியே I about y will be what? M into x square. Just add this to Ix plus Iy. What we will get? M into x square plus y square. Then can you tell me what about Iz? Zx in perpendicular distance is only know. What is that? M into root over x square plus y square whole square. It is nothing but m into x square plus y square only, no, which is equals to this only, right? So Iz will be equals to Ix plus Iy. So moment of inertia about the axis which is perpendicular to the plane of rotation passing through center of mass will be equals to sum of the moment of inertias. The remaining two axes which are passing through the same point and perpendicular to each other as well as perpendicular to this one axis. Am I clear? Okay. Now see. Now see. An example. For this also an example I'll give. Disk. Axis along x, axis along y, axis along z. Mass m, radius r. Okay. Can you tell me what is the moment of inertia about x for this case? It's not one axis. It's just passing through center of mass, but not one axis. How to calculate it? Very simple. I about z, we know that m r square by 2. Center of mass of disk about center of mass axis. Moment of inertia of disk about its center of mass axis what? Mr square by 2. So I can say that mr square by 2 is equals to ix plus iy. It is nothing but 2 times of ix only, no? Why? Because however, however the masses distribution is happening for x-axis, same it is happening for y-axis, because above the axis half of the mass is there, below the axis half of the mass is there. Like that y-axis, if you see, left side of the y is, right side of the y is half mass, left side of the y is half mass. So mass distribution for x-axis and y-axis is exactly same, which means moment of inertia about x and y will be same. So ix will be what? Similarly, iy will be what? Got my point? And remember, perpendicular axis theorem is only valid for, it is only valid for two-dimensional laminal bodies. Two-dimensional laminal bodies. Like disk, ring, sheet, and the marina. Not for 3D objects like hollow sphere, solid sphere, or not for 1D objects like rod. It is only valid for two-dimensional bodies. But parallax theorem is valid everywhere. There is no limitations for it. We can apply parallax theorem everywhere where there are two parallel axes, one of them is passing through center. Got it? Now, by using both of these equations or these theorems, let us do some questions. Okay, let's do some questions. Try this one. Disk only or ring of mass m, ring of mass m, and radius r. Now I want moment of inertia of this ring about the axis passing through its tangent, passing through its edge, and parallel to the plane. Parallel to the plane means I'll just show you. This is the ring, axis this. This is the plane of the ring, parallel to that axis. If ring is rotating about this axis like this, what will be the moment of inertia? Okay, think of it out today. Just think. Whether parallel axis theorem is applicable or not, perpendicular axis theorem is applicable or not. Just think of it. I'll give you 2 minutes time. Axis, right? I want moment of inertia about this axis. I know moment of inertia about center of mass axis, which is passing through the center and perpendicular to the plane. What is that? Mr square by 2. Sorry, Mr square, ring no. So by using this perpendicular axis theorem, by using perpendicular axis theorem, about this axis it is Mr square. Then this will be how much? This plus this is equals to this, as like previous question. So this will be how much? Mr square by 2. According to perpendicular axis theorem. About z axis Mr square. About y axis how much? Mr square by 2. And here one more axis there. Now parallel axis theorem is applicable, right? Because this is passing through center of mass and this is parallel to it. So about this what we can write? ICM, which is parallel to this, plus m into d square. What is ICM? Mr square by 2. What is m d value? So how much will be? 1 plus 1 by 2. Is it clear or not? Okay, okay, wow. Now one more question. This you have to solve until disk is there of mass m, radius r. It is disk. I want moment of inertia about an axis passing through its edge and perpendicular to plane. இப்படி இது ரிங், சாரி இது டிஸ்க்னு எடுத்துக்கோங்க. ஆக்சிஸ் இப்படி இருக்கு, இப்படி கிடையாது, இப்படி இருக்கு. ஓகே ஆர் நாட்? This is okay. Think of it. I'll give you 1 minute, 2 minutes time. Hello. Yeah. Tell me what is your answer. See, the disk is like this, and axis of rotation is this. So directly you can apply parallel axis theorem. No, center of mass axis theorem. About center of mass axis, we know moment of inertia, which is mr square by 2 disk. No? And these two are parallel only. No? This one and this one. So it will be edge axis will be mr square by 2 plus m into r square. What will be the answer? 3 by 2 ag meter square. Right? Got it? அப்படி x அப்படி இல்லையே, x is not like this, x is like this. When axis is like this, parallel axis இது பார்க்கணும். When axis is like this, parallel axis தானே. So this is already going through center of mass and perpendicular to axis of rotation, plane of rotation, which means it is one axis. One axis would moment of inertia m by mr square. Next, try one more question. There are 3 rings. Third one is not good. There are 3 rings. Each of mass m, radius r, identical rings. And axis is passing through the 3 rings combination like this. Like this. Actually, it will be like this. Ring 1, ring 2, ring 3. Okay, ring 1, ring 2, ring 3. Axis like this, which means it exactly passing through center of the bottom ring. Okay, then what is the moment of inertia of the system? About the given axis, about this axis, what is the moment of inertia? Think. Pen வச்சு சால்வ் பண்ணாதான் ஆன்சர் வரும், பார்த்தா வராது. சால்வ் பண்ணுங்க. 3 by 2 mr square. So same for this 2, no? What is this? 3 by 2 mr square. This is 3 by 2 mr square. What about this axis? Mr square by 2. passing through center on the plane. Parallel axis, perpendicular axis apply பண்றது. So what is the total value? 2 times of 3mr square by 2 plus 2 times of mr square. Mr square by 2. 1 minute. It is 2 times per hour. Sorry. 2 times of mr square by 3 by 2 mr square plus mr square by 2. What it will be? 7 by 2 mr square. Rida, all of you, is it clear? Online batch. Next. One more question. Try pannu. There are 4 massless rods. I am taking rods as massless. At the corners of this square shape, 4 solid spheres of mass m, radius r are placed identical. Then what is the moment of inertia? First question. About the axis like this. Okay. And the center to center distance is 5r. Center to center distance is how much? 5r. All the cases. This is question number 1. Moment of inertia about this axis is how much? One more question is, if the axis is passing along the diagonal, what is the moment of inertia about this axis? Do it fast. 4 solid spheres, okay, solid spheres. Identical only. Solid spheres which are identical in mass and radius. MR square formulas kuda padikala. About this axis, for all the 4 spheres, parallel axis theorem if we apply, what it will be? About center of mass 2 by 5 mr square plus m into distance total 5r. Adil is r. So remaining will be how much? 3r. So in that if you see this distance, how much will be? Exactly half. Appadina 2.5r dana 5r la half. It is half of the 5r. So 5 by 2 into r whole square. Like this, how many spheres are there? 4 spheres. So 2 by 5 mr square into 4 plus mr square into 25 by 4 into 4. So this 4 will get cancelled. So here 2 into 4, 8, 8 by 5 plus here, how much will be? 25. Common out, mr square. So 125 plus 8, 132 by 133 by 5 into mr square. This is what total moment of inertia. Basic formulas padikinunda. Next, moment of inertia about the diagonal axis part. Here also parallel axis theorem can be applied because it is 3D lamina, 3-dimensional bodies perpendicular axis point varadu. So parallel axis theorem apply panna. Parallel. If I take moment of inertia about this axis, it is 2 by 5 mr square. This is what parallel distance, parallel axis or distance. So full how much will be? This is 5r. This is 5r. What about this? 5r into root 2 divided by 2 half of that. So 5r into root 2 by 2. That means 5 by root 2 into r. Same for this also. 5 by root 2 into Then the total moment of inertia I can write. See here the axis passing through center of mass only. For this there is no need of parallel axis here. So two spheres are having moment of inertia 2 by 5 mr square. That's clear. Plus remaining two spheres parallel axis 0, which is 2 by 5 mr square plus m into distance. Distance is how much? Pi by root 2 r whole square. Now simplify this. 4 mr square by 5 plus 4 mr square by 5 plus 2 mr square by 2 into 25. 2 will get cancelled. 4 mr square by 5 plus 4 mr square by 5, 8 mr square by 5 plus 25 mr square. What it will be? Mr square common out, 8 by 5 plus 25. Same it came up. It's coming out to be same. Huh? Yes, it's coming out to be same. How much it is? 125 plus 8. 133 by 5. Same. What a coincidence. How much you have got? Two spheres, 2 times of 2 by 5 mr square plus 2 into 2 by 5 mr square plus m into d square. D is 5 by root 2 whole square. 25 by 2. Here one more 2 is there. If it is multiplied inside, 2 times of mr square by 2 into 25. Yes, 2 will get cancelled. So 4 by 5 mr square plus 4 by 5 mr square. Yes, 8 by 5 mr square plus 25 mr square. Correct? Understand? Okay. Like this, whatever the questions are there related to moment of inertia. Now itself I'll post the question paper and parallel and perpendicular axis theorem completely. Okay, tomorrow next class we need to start angular momentum. That will take one full class. In terms of examples, let me take the photos.